So students, now we discuss about Fresnel's diffraction. In the Fresnel's diffraction, Fresnel actually divide the wavefront in some circles AB and CD is a plane wave front. Actually, in Fresnel's diffraction, in the previous class, we see actually there the two wave front is used, actually spherical and cylindrical. But we use the plane wave front because actually we make the calculation easy. For easy calculation we take this type of wavefront, plane wavefront. So this plane wavefront and Fresnel divide this wavefront in some circles or regions or zones. Now actually this zones is called, which he named as half period zones. Half period zones. Now the wavefront, and from the wavefront P, where we measure the intensity, the amplitude, actually the intensity of the light comes from this wavefront. Now if the distance between the center of the wavefront O and the distance from the center of the wavefront and the P point is B. Now why the region zones, actually half period zones? Because the zones, actually if this is the first zone and this is second zone and this is third zone and so on, if this is nth zone, I take this. Now why this is half period zones? Because Fresnel take these zones, if this is the center and this is the second zones, actually if the distance is B between the center and the point P, and this is the second zone, which is the distance from P, actually B plus lambda by 2. Actually the circle is drawn, actually if the distance is B and if the lambda by 2 is this extent, from this extent is this length is lambda by 2. Now if this is the circle, this is the central O and P, the distance between P, this is actually B length, and if this is the lambda by 2, then he draw the circle, actually P. So this distance actually B plus lambda by 2, and draw from here, from P, actually P as a center, and he draw the circle from here. So this is the circle which have the distance from P, from point P, actually B plus lambda. Every point of the circle, of this circle, actually the distance from the P, from point P, actually B plus lambda. So this is B and this distance is B lambda by 2, which is this distance is lambda by 2, and from P he draw the the circle in which the circle's every point, actually the every point of this circle is distance between the p and the every point of the circle is b plus lambda by 2. Now this actually from there the distance is b plus 2 lambda by 2. Actually the distance are lambda by 2, actually difference between the two zones lambda by 2. Now this is nth zone, so the distance between p and the circle, the nth zone, is b plus n lambda by 2. Now if this is the center O and if this is M and P, now radius of nth zone, nth circle radius, if we radius from, we get the Pythagoras law, we get the actually from triangle law, actually OM square plus OP square equals to MP square. Now OM square actually Rn square, which is Rn actually radius of nth zone. Now why this is half period zone? The difference between the distance between two zones, actually lambda by 2, and phase difference is pi. We know that 2 lambda, for 2 lambda actually phase change is 2 pi, lambda, for lambda path difference is phase difference is 2 pi, so lambda by 2 path difference, so pi is the phase difference. And what the time period? Now for lambda actually time period or the difference between the time, actually time period, so this is t. So if they are lambda by 2, so the time period actually t by 2. This is the difference between two zones, so that differences between their time period is t by 2. So this is the half period zones. So why the half period zones? Because their time period actually t by 2, the between the two zones, actually the time period, the difference between the time periods actually t by 2, and their path difference actually lambda by 2, and phase difference pi. Now Rn square equal plus OP square. OP square means OP actually b square, and MP square actually b plus lambda by 2 whole square, n lambda by 2 whole square. Now Rn square plus b square equals to b square plus 2 n lambda b by 2 plus n lambda by 2 whole square. Now 2 is cancel out, n lambda, and b square cancel out, so Rn square equals to n lambda b plus n square lambda square by 4. And now this actually n square and lambda square, lambda is very small, so this term is negligible, so this term we can neglect. And now Rn actually root over of n lambda b, so we can also we can also get from this Rn varies as root over of n, where n actually natural numbers actually 1 2 3 1 2 3 dot 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 1 for actually first zone and 2 for second zone. So we can get first half period zone, for first zone actually radius r1 equals to root over of lambda b, and for second zone r2 equals to radius of the second zone actually 2 lambda b, and so on. So nth zone Rn equals to root over of n lambda b. So these are the radius of the zones. And now if we calculate the area of the zones, so if we calculate this actually nth zone, and if this is n minus 1 zone, now if we take the nth zone area, nth circle area, and this is the n minus 1 zone circle. So this if we take these two actually circle, now area of nth zone an equals to pi rn square, the area of nth circle, and minus pi rn minus 1 square, now equals to pi rn square. Actually we get rn actually root over of n lambda, so n lambda b minus pi n minus 1th zone, actually n minus 1th zone, for n minus 1th zone r n minus 1 is equals to root over of n minus 1 lambda b. So n minus 1 lambda b, now pi n lambda b minus pi n lambda b and plus pi lambda b. So these are cancel out, pi lambda b. So for area of nth zone is actually pi lambda b. So this is actually constant an, because there is no n, actually there is no n. So this is the constant, pi constant, lambda b actually constant, so an actually constant. So for a1 actually area of first zone is equals to pi lambda b, area of second zone pi lambda b. So these are constant, so on, but their radius actually a r1 equals to root over of lambda b, r2 equals to root over of 2 lambda b. So their radius varies of root over of n, actually square root of their the natural numbers, but their areas actually constant. So this the area of nth zone, or this the areas of half period zones. So thank you for watching the videos. Actually we learned from this video radius, which is actually rn, varies root over of n, and an which is constant, area. And why this is half period zone? Because the distance between two zones is lambda by 2, difference between the distance from P is lambda by 2, and if the lambda by 2 is path difference, then phase difference is pi, and if phase difference is pi, the time period difference is pi. This is the phase difference pi, and so if the time period t, total t is, and phase difference there the pi, and path difference there lambda by 2, so this is the difference between two zones. Time difference between two zones is t by 2, so this is the half period zones. So thank you for watching this video, and if you like this video, you subscribe my channel and share my channel. Thank you for watching the video.